So have you started like numerical like? Did you practice numerical? Any numerical? Dinesh,
Yes, sir.
did you practice numerical like?
Sir, no, sir. Like yesterday, I was preparing for JEE exam, sir. Like
Okay, please
preparation
practice.
exam.
Okay.
Okay, sir.
Which topic is going on in your JEE batch?
Sir, motion in plane.
Motion and plane. Okay. No worry. Yes. If you have doubt from JEE also, you can ask also. Okay.
Okay, sir.
So write down a question. Find moment of inertia about the given axis. Given axis. So I will draw the diagram. Give me the answer. Okay.
Okay,
This
sir.
is the rod. Center of mass. You need to find the moment of inertia about this axis.
Okay, sir.
Okay.
Okay, sir.
Rod mass is small m or capital M, you can say. Length is capital. Okay.
Okay, sir.
Solve this. This distance is from center. This is L by 4. Okay. So it is very
Okay,
easy
sir.
like parallax theorem. You know parallax theorem.
Yes, sir.
So how to apply parallax theorem? For example, this is the body. If you know the moment of inertia about the center of mass, then if they are asking what is the moment of inertia about this axis, let us suppose I, this distance between the two parallel axes is d. So what is the moment of inertia? I will be, moment of inertia about the center of mass will be IC. Clear? So answer will be IC plus, for example, system is having the mass m or body is having the mass m, multiply square of the distance between them, like this. Clear?
Okay, sir.
This is what we have learned. Okay. Any doubt?
Yes. No, sir.
To solve a simple question like, you should know the relation like, I'm asking what is the moment of inertia about this axis. Then you must
So
know
one
the
minute, sir.
axis. Parallel to this axis, you must know what is the moment of inertia about the center of mass. That is ml square by 12. Okay.
Okay, sir.
Now I will be what? ICM plus m multiply square of the distance between the two
L
parallel
by 4
axes.
the whole square. L by 4 the whole square.
Very good. Clear. So ICM is ml square by 12
Plus
plus.
ML square by 16.
Tell me the final answer.
1 minute,
Comes
sir.
out to be, if you solve, you will
ML.
get 7 ml square by 48. Okay.
Okay, sir.
Is it clear?
Yes, sir.
Hmm. Moving to the next question. Write down the next question. Rod is like that. Okay.
Okay, sir.
An axis is placed like this. This is the axis. Okay.
Okay, sir.
About which I need to find the moment of inertia. Distance is how much from the center? L. Clear? So it is very
Okay, sir.
easy question. You should, if they are asking like, you should know the parallax theorem. So you should draw the parallel axis with respect to current axis. So parallel axis you should draw with respect to this. It will be like this. Okay, it is passing through center of mass. Okay,
Okay, sir.
it is 0. Clear? IC is 0.
Okay.
So I is equal to IC plus ml square. IC is 0 because you know this. For a rod, if axis is passing like this, it is moment of inertia is 0. Okay, it is parallel to length. Okay,
Okay, sir.
this axis. I just remind you. Clear? So it is
Okay, sir.
0 plus ml square. So what is the answer? I will be ml
Jamal.
square. Is it clear?
Ah, yes, sir.
Any doubt?
No, sir.
Moving to the next question, like write down the question. Find the moment of inertia about the given axis. Given or given t.
Thanks.
Clear?
Okay, sir.
So what I'm asking, like given axis. Okay. So I will draw the diagram. You please give me the answer. Okay.
Okay, sir.
T shape is rod. One rod is here like this. Okay. And one rod is like this. Now about which is the T shape. Okay. Now my question is,
Okay.
what is the moment of inertia about this axis? Clear?
Yes, sir.
Please tell me the answer. What is the answer?
Sir, what is that length of this rod, sir?
Length of this rod is L, small L, capital L. Can take.
Okay, sir.
Okay.
Okay, sir.
Mass is M. Here also M.
Sir,
Clear?
we should use parallel axis theorem.
You can use, but you know very well, like you can use
Sir,
parallel axis theorem. About this axis. You need to find the moment
sir,
of inertia.
zero, ml square.
Wait. I'm telling. One minute.
Okay.
This T is made up of two rods. Okay.
Okay, sir.
If I ask you, this T is made up of two rods. Tell me the answer here. It is one T, one like one square rod, one square rod like this. Okay.
Okay, sir.
Due to this rod, you can take give number one. You can give number two. Okay.
Okay, sir.
So due to this second rod, what is the moment of inertia about this axis? See, what will be? I will be. We can say what? Due to second rod, due to first rod. Okay. Any doubt?
Okay.
Now due
No,
to
sir.
second rod, how much? See second rod. This
Sir,
axis
ml.
is parallel to this. Okay. So ml square, very good. Ml square. Is it now?
Ah, yes, sir.
Plus I1. Due to this rod, due to this rod, this axis is one of the end. Clear? If you know
Okay, sir.
this, like for a rod, if axis is passing through one of the end, Clear? If mass is m,
Okay.
length is L. Clear? If this is the axis which is passing through one of the end of this rod, like this, then moment of inertia is ml square by 3. Do you remember this?
No,
Clear?
sir.
Did you
Ah,
revise the
yes.
formula? Tell me.
Yes, sir. For rod, for plate, for
Hmm.
solid hemisphere, for hollow cylinder, for ring, I have remembered,
No,
sir.
ml square by 3. So answer will be 4 ml square by 3. I will tell, don't worry. If you don't know, I will tell. If rod is there, okay, for a rod, if axis is passing through the center of mass like this, and it is perpendicular, okay,
Okay, sir.
rod length is L. If this is L, this is L by 2. Clear? This is
Yes,
also
sir.
L by 2. I am asking, what is the moment of inertia about this? That axis is passing to one of its end. Then we will use the parallel axis theorem. Clear?
Yes,
Moment
okay,
of
sir.
inertia about this axis IC. So I dash will be what? IC plus mass of the rod multiply the square of the distance between them. Like this. Clear?
Yes, sir.
IC is what? You know very well ml square by 12. Axis passing through the center and perpendicular to its plane. That is ml square by 12. This is parallel to this. I want to know this. Clear?
Okay, sir.
This axis is passing through one of it end. This axis passes through one of its end. Clear? Two ends na, one end is there, one end is here, and it is perpendicular also. Okay?
Okay, sir.
So it will be, what is the moment of inertia? ml square by 4. 3, I can do 3 here. So I dash will be what? 4 ml square by 12. Okay? So what is the answer?
Okay, sir.
ml square by 3. Is it
3.
okay? Is it clear to
Ah,
you?
yes, sir.
Any
Yes,
doubt?
sir.
Still
No,
you
sir.
have doubt, you can ask me anytime. You have any doubt?
No doubt, sir.
Okay. Shall I move to one more question?
Ah, yes, sir.
Okay. Now write one small question like, write down, find the moment of inertia about the given axis. This is the ring. Okay. Center, radius, clear? This ring is having the mass small m. My question is, find the moment of inertia about this axis. It is tangent to this. Clear? Fine. What is the answer?
Okay, sir. One minute.
Take your time.
Sir, 2 mr square.
2 mr square. Okay, right answer. So easy only. Okay. So you
Okay.
know like this is a ring. Okay, ring. And for the ring, like about the diameter, its diameter will be like this. Okay.
Yes,
So
sir.
about this diameter, moment of inertia is, you can say it is actually passing through center. Okay.
Okay, sir.
Our main objective is the axes which are parallel. One of the axes must passes through the center. And you must know though both the axes must be parallel. Clear? Here distance is r.
Okay, sir.
Very easy. It will be IC plus MR square. Clear? So what is the
Yes,
answer?
sir.
For ring diameter, about diameter is MR square by 2. Okay.
Okay, sir.
So answer is 3 by 2 MR square. Is it okay?
Okay, sir.
Got it? This
I
is
did
the
a mistake.
actually, yeah, no problem. First you are learning now. When you are learning, then you will commit mistake. This is diameter actually. And it is passing through center. And this is the axis about which you know the moment of inertia for ring. Clear?
Yes, yes.
Okay. Can I ask one
Okay,
more
sir.
question?
Yes, sir.
Okay. Write down the question. Find the
Sir,
moment
one
of
minute, sir.
inertia.
For ring, the moment of inertia passing to the axis passing to the center will be mr square only, no, sir.
Yes, yes. From center it is perpendicular. Na? For diameter, this is 2 diameter. About diameter, it is mr square by 2. For from passing through center, it is mr square.
Sir,
Okay.
if we like tilt the ring, it will be like diameter, no, sir. That axis will be like act at diameter only, no, sir.
Ha. See, our diameter is passing through center. This is the axis. And I'm asking what is the moment of inertia about this axis which is tangent to this ring and it is parallel to dia. I want to know this. Two axes are parallel, na?
Yes, sir.
That's why directly I have applied. But this is not parallel, na? You just tell me. Our MR square which I have written that is perpendicular to the plane of the ring. It is not parallel to this. Condition is for parallel axis theorem, two axes must be parallel and one of the axes must passes to the center of mass. Clear?
Okay, sir.
Then this moment of inertia I will be what? About C plus m into square of the distance between them. Like this. Okay?
Okay, sir.
So write on the next question. Find the moment of inertia about the in starting everyone is making mistake. Okay, because we are learning
Okay.
and when we are learning something new we make mistake, so no need to worry. Nobody is a
Okay, sir.
Newton, nobody is a Einstein in his first attempt. Okay, we are learning, we are
Okay.
gaining experience, then move on. This is the disk.
Sir, I can't really understand like how mr square by 2. Ring only, no, sir. If we like
I'm
rotate that
telling
ring,
i'm
that.
telling i'm telling 1 minute. This is ring. Okay,
Okay, sir.
this is the center and this center is passing through this like this, like this. It is perpendicular to the plane. Okay, clear? About the center, what is the moment of inertia? Mr square. Okay.
Okay, sir.
If I am asking like, what is the moment of inertia about dia? So like this is dia. Okay. And this is also a dia. Clear?
Okay, sir.
And this is both are perpendicular. If you look at this dia is perpendicular to this. This X or Y. This is Z. Okay.
Okay, sir.
So I is at perpendicular axis theorem. Three axes are mutually perpendicular. So I can say IZ will be IX plus IY. Clear?
Yes. Yes.
Since body is symmetrical, if you cut same mass here, same mass here. If you cut like this is the axis, same mass is here, same mass is here. Okay, if axis this, same mass is here, same mass is here. If diameter you are drawing like this is the same mass is same mass is here. So if you take any diameter, if you take diameter like this, okay, that is passing to
Okay.
center, then always there is symmetry. Clear? Then
Yes.
this Ix will be, if symmetry is there, already I have told. Symmetry is there, then they have the same moment of inertia, either of the axes. Clear? Okay.
Okay, sir.
Then Ix is equal to Iy. So I can write like Iz is mr square. Ix is equal to Iy means Ix plus Ix, 2Ix. Okay. So Ix
Okay,
will be
sir.
mr square by 2. Is it okay? So actually this moment of inertia about x-axis means it is the diameter, no, actually. Clear? So we can say this Ix which I have calculated mr square by 2. Actually, I can say it is the diameter, moment of inertia about the dia. We can say like this. Clear?
Okay, sir.
Any doubt?
No, sir.
Okay. Moving to the next question, like I will ask on the next page. Uh, Write down the question. Find the moment of inertia about given axis. Clear?
Yes, sir.
This is the disk. Okay. Center of the disk. And four masses are placed. Okay.
Okay, sir.
So masses are placed. One mass is placed like this. One. Okay. One mass is here.
Okay.
Okay.
Okay, sir.
And you can say 1 minute. I think should I have drawn wrongly. Okay, yeah. Okay, all right, all right. Should actually I'm thinking what I should ask. Yeah, okay. About this axis. Question I have framed actually. Tell me about this axis. Solve this.
Sir, what are the three dots, sir?
These are the three masses placed on a disk. Small point
Okay, sir.
masses. And these are placed R by 2. Okay?
Okay, sir.
Clear?
Yes, sir.
Solve this. Easy question only. Clear? You just
Okay, sir.
understand because axis is fixed. We are not changing the axis. Clear? Hello. Hello.
Sir, will you have to
हाँ
find the moment of inertia for
हमने
different
हमने हमने
separate
हमने
point
कहा हमने
masses?
कहा कि 5 हमने कहा 5 4 कितना बोल दिया था about this बोल दिया क्या about कितना this अच्छा 4
Okay.
50 नहीं
550 अभी कितना हुआ मतलब अभी 5 मिनट हुए हम लोग को आए क्लियर पहले बोल दिया 450 बोल
Yes, sir.
सवा 5 बजे हाँ तो उस
So simply like this is actually what since
हम 450 पे अपने
axis is
थे तो वही वाला टाइम आपको बता दिया था
okay.
नहीं 450 में हम आए
So
10 मिनट तक खड़े रहे फिर वही हाँ वही
we can add moment of inertia like a scale.
हाँ ये तो थे ना हाँ वो नहीं हाँ वो राहुल हमसे बोला कि 450 में बोला कि सर चलिए आगे
Is it okay?
डन कर रहा हूँ लाइव पर
Sir, yes, sir.
So I will be what? What is, you know, this is made up of what? I will be total moment of inertia. Actually, about this, it will be moment of inertia of disk plus moment of inertia of particles.
हमें जो कहा हमें आई बाइक उधर फिर
Okay.
So for disk, if you look at carefully,
Sir, can you please like repeat again like how we are adding like scalar?
since axis is fixed, okay, axis is fixed, already have discussed, moment of inertia behave as a scalar. Okay.
Oh, okay, sir.
Since this whole arrangement is made up of disk and plus particles. Okay.
Okay, sir. Okay, sir.
So total moment of inertia about this given axis will be moment of inertia of disk and moment of inertia of particles. Clear? Is
Yes,
it
sir.
okay? For disk,
Okay, sir.
if you look at carefully, for disk, if I ask you about this, what is the answer?
Sir, the normal it's like sir, for the axis above the center it is MR square by 2.
You know what is, if I ask for this is our disk. Okay.
Okay,
Center
sir.
is here. I'm asking about this. This is R. Okay. Clear?
Yes, sir.
So for disk about what is the moment of inertia of this disk about this axis? It will be, I need an axis that is parallel to this axis. It is diameter. Okay.
Yes.
So it will be ID plus MR. Clear? Is it okay?
Yes, sir.
For
Sir,
particles,
that ID means sir, what is that ID?
ID
Diameter?
means diameter.
Okay, sir.
Axis that is this is diameter, na? Or you can say ID or IC, whatever.
Okay, sir.
Because diameter and center means axis is passing through the center. Clear? For
Yes,
particles,
sir.
if you look at the particles, all the particles, this particle, and this particle, from the axis, how much? If I ask you for this particle, it will be having to, for for point mass. For point mass, I is equal to mr square. Okay.
Okay, sir.
What is r? R is the perpendicular distance of a point mass from the axis of rotation. Okay.
Sir, R by 2.
Yeah, very good, very good. R by 2. Okay, for second
For
mark.
third one, sir, for second one, R plus R by 2.
Very good. For third
3R by
mass,
2.
3R by
R
2.
by
Very
2,
good.
sir.
Now please solve this and give me the answer. Total. ID is what?
Okay.
ID is mr square by what? 4. Disk is also having the mass M, capital M. Or if you
Okay,
want,
sir.
like you can take small m. Clear? You can take a small f. So symmetry is there, okay?
Small m. Okay, sir.
mr square by 4. Clear? Solve.
Okay, sir.
So once you solve the whole question, it will be just solve this. It will be 7 mr square by 4. Once you solve mr square by 2. Did you solve this?
So I'm solving, sir.
3 mr square, what is? Maybe it is 3 mr square. You just solve, okay? You tell me it is 3 mr square, what? It is the
Sir,
answer.
here power cut, sir.
Power cut. Okay,
Yes,
then
sir.
we need to stop the lecture.
Sir, answer is 13 mr square by 4.
13 mr square, not possible, beta. No. I think 7 mr square by 2. This is the answer. Okay, I'm writing here. We just solve 7 mr square by 2. Okay, if you solve this,
Okay.
only, you will get mr square by 2. Okay,
Okay,
for
sir.
this total, if you solve, it is mr square. Okay,
Okay.
power, but power is not there. Are you able to join, or is it
Sir,
okay?
you can teach, sir. I'll use
Okay.
emergency light.
Okay. Next question is, like, if I ask you,
Sir, can you please repeat that previous answer?
huh, answer is 7 mr square by 2. You try, the simple calculation is there. Okay.
Sir, for what is that value of ID?
ID is mr square by 4 for disk. This is disk.
Okay.
Okay. About diameter, it is mr square by 4. Clear?
Sir, then ID plus M. Sir, 1 minute, sir.
You solve. Okay. Try. Do the calculation.
Sir, for this, the sum of this will be 2 mr square by 4 only, no, sir.
Then mr square by 2, na?
Okay, sir. Then for this one, I got 11 mr square by 4.
Hmm. Okay. It is mr square by 2. For this, it is coming out to be how much?
11 mr
For
square by
particles, it is
4.
mr square. Just solve again.
Oh, okay, sir.
Check again. What is your answer now?
One. Sir, I got 13 mr square by
How
4.
is it possible? Like I'm telling, okay? 1 minute. For particle, I think you have doubt now.
Sir, I got power came, sir.
Okay. mr square. This is the, okay. Basic calculation. Actually, you are making mistake. Simple calculation. No worry. I will discuss. Okay. For
Okay,
particle,
sir.
mr square by 4 plus mr square by 4. 3 mr square. Sorry, 9 mr square by.
4.
So what is that? 9, 10, 11, I think. Okay.
Okay, sir.
Is it the same answer you are getting?
Yes, sir.
Mm, okay, there are 3 masses. Is it the same? Okay, for maybe we can commit Mr. Disk, you are getting mr square by 4 plus mr square by 4, that is mr square. So once you add, you will get what answer? About 4, 15 mr square by 4. That's why I'm saying like cross check. Okay.
Okay, sir.
15 mr square by, what is it now? Okay.
Okay, sir.
Any doubt?
No, sir.
Okay. Next question, right on. This question is little bit tricky. Maybe I will give you homework. You write this
Sir, but
question.
here, sir, for mr square by 4 and mr square by 4, if we didn't cancel, we get 2 mr square by 4, sir.
You know, take the LCM, na? 4. So 9, 10, 11.
Sir, not for that, sir. For id plus m r by 2 the whole square.
So for ID actually, if you look at carefully, for ID disk, about diameter it is mr square by 4
4.
plus mr square, because square of the distance between the two axes.
4.
It is mr square by 2.
Sir, 2 mr square by 4. Like, we can write like
So
that
what I
also,
have
no,
written
sir?
na 2 mr square by 2 na earlier. That is okay na. So it will be what? Total will be 2 mr square by 4. That is 11 mr square. Actually, my mind is somewhere else today. That's why here. Okay, 13 mr square by 4. Okay, really sorry for that. Okay, your answer is correct.
Okay.
13 mr square by 4. Is it okay?
Okay, sir.
Write our question. It's the last question, and we just practice question, or else I'll start new topic. What's your?
Okay.
Shall I start new topic, or I will give question? Okay. Write down the
Okay.
question. 4 rods, each of mass m and length L are joined to form a square. To form a square. Find moment of inertia, the given square. 1 minute, okay.
Okay.
One day I will take your test also, okay. Practice.
Okay.
Square
Sir, on which topic, sir?
moment of inertia. Topic wise, okay.
Oh.
About
Okay.
one of its diagonal. Clear?
Yes, sir.
I'm not available in coming days, maybe tomorrow. Clear?
Okay,
So
sir.
we can't take our class tomorrow. So maybe on Sunday. Simply, if you ask me like how to draw the diagram, I will draw 4 rods. One rod, each of mass m, length L. Clear?
Okay, sir.
This is also one of the rod. Clear?
Yes, sir.
And every rod is having the mass m. And its length is L, length is L, length is L. Clear? What I am asking,
Yes, sir.
find the moment of inertia of the given square about one of its diagonal. This is diagonal, okay? So about this diagonal, you need to find the moment of inertia. Okay? This is your task.
Oh.
And I am telling like since the body is symmetrical, If you draw the diagonal like this, hint I am giving, symmetry is there. If you draw the diagonal like this, symmetry is there. So about this I, about this also I. Okay, and they are at 90. Now what you will do, you just calculate the moment of inertia of all the rods about the center which is passing through Z. So this you should apply Iz equal Ix plus Iy. Ix is I, one of the diagonal, again I. So it will be half of Iz. How to calculate Iz? This is your task. Okay.
Okay, sir.
Don't worry, tomorrow I will explain. Center of mass will be at the geometrical center. Clear?
Yes, sir.
Any doubt?
No, sir.
Okay. So I will start a topic like we have many questions. Like I will give some question like in your test. Don't worry, you will learn a lot of things. Clear? So I will start a new
Okay.
topic like angular momentum. 1 minute. I will close the slide. One minute. Okay.
Okay, sir.
Just a little bit. Hmm. Is my screen visible to you currently?
Sir, that homework question. Yes, sir. Angular momentum.
So I will discuss little bit introduction of this, then we'll sum up the lecture. Okay. So like
Okay, sir.
you have learned like linear momentum. Linear momentum is mass into velocity. Okay. F is
Okay,
equal
sir.
to dp over dt. This is what you have learned. Rate of change of momentum is equal to force. In the similar way, here angular momentum. In place of P, there is L. L. In place of mass, there is I. In place of V, there is omega. So in case of rotational motion, this is known as angular momentum. L is angular momentum. Okay.
Okay, sir.
For particle, it is different. Okay. For particle, it is different. For body, it is different. Okay. Is it okay?
No. Yes, sir.
Now look at here. So I think this is clear to you. We are well aware about the concept of linear momentum. Now let us move one step ahead and study what is angular momentum. Clear?
Okay, sir.
So what is angular momentum? It's a physical quantity similar to linear momentum. In translation motion, already I have explained what is translation motion. Clear? It is also called moment of momentum. Clear? Moment of linear momentum. Like torque. Torque, I think you are familiar, R cross F. Okay.
Yes, sir.
So what is the
Okay,
meaning
sir.
of torque? This is force. Tau is what? Torque, or we say movement of force. Okay.
Okay, sir.
So angular momentum is physical quantity similar to linear momentum in translation motion. It is also called moment of momentum. Clear? For a
Yes,
given
sir.
particle, angular momentum is given by R cross P. This formula very important. What is R? I'm telling. You just remember, for example, this is the axis. Okay.
Okay, sir.
And a particle is here. For example, this is the particle. What is the moment of angular momentum of this particle about this axis? Okay. So
Okay, sir.
from this is center of mass, for example, axis passing through center of mass, then R vector is from the center, like this. You are giving certain velocity to this, like this. Okay. So its
Okay,
angular
sir.
momentum will be r cross p. Here, rp sin theta. L will be r cross p. In vector form, you can say rp sin theta. What is the direction? I will tell. I will convey. Clear? What is momentum? Mass into velocity. mvr sin theta. Clear?
Okay,
Direction I
sir.
will tell. Direction will be given by what? R cross P. R cross P or R cross V. Okay.
Okay, sir.
So this is a considered rigid body that is rotating about an axis that is passing through O and perpendicular to its plane. Clear? Rigid body consisting of n particles having mass m1, m2, mn. There are n particles. Clear? Is it okay? And
Okay, sir.
every particle is that different position, like r1, r2, r3. These are the position vector. Clear? Let the angular velocity of all the particle is omega. Already I have told. If a particle is doing pure rotation, then its angular velocity never change. Omega remain constant. Clear? In
Yes,
starting
sir.
first lecture, I have explained this. Clear? Now see.
Okay, sir.
Do you see one thing like? Now see. If a particle, all the particle, for example, this particle will move in a about this axis, it will move in this circular path like this. Okay. This
Okay, sir.
particle will move in this circular path. This particle will move in this like this. And tangent to any circular path will give the velocity. Okay.
Okay, sir.
And if any particle is moving in a circular path, okay, this is for example R1, this is V1, okay, center, this is the axis, it is going like this, okay. Then V1 will be what?
Okay, sir.
R1 omega. Okay.
Okay, sir.
Linear momentum of mass m1 is mass into velocity. For second particle, like this. Similarly for nth particle, like this. Okay. So
Okay,
when
sir.
when this whole body is going to rotate, okay, then all the particle inside this body is also rotating about this axis. Clear? Then if you want to know
Mm,
the momentum, the moment angular word we will use here because there is rotation. Clear? So if you want to know like what is the angular momentum of entire rigid body or entire body about this axis, then we will do what? We will sum up all the momentum of these particles. Clear? Because body is made up of infinitely small particles. Clear? For one particle
okay,
it
sir.
is m1 r1 omega, second particle m2 r2 omega. Clear? Like this.
Yes, sir.
Is it okay for you? Now L will be what? You can check P1 into R1. Okay. The formula of a single particle, like if I ask you, this is the formula, na? L will be 1 minute. M R cross V. Okay.
Okay, sir.
And if you take this mass inside, then it will be R cross MV. MV is momentum. This is angular momentum of single particle. Okay.
Okay,
If you
sir.
want to know L1, L1 will be M into R1 V1. V1 is R1 omega. Okay, it will be MR1 square omega. Now, what is the direction of this? We will calculate by R cross V. Okay,
Okay,
R
sir.
cross V. So you just tell me R. For example, this particle R vector will be like this. Okay. And this is the V velocity, V vector. So R cross V, if you check, like it is perpendicular to the plane like this. Okay.
Okay, sir.
Right hand thumb rule, I think you are familiar, is screw rule. Okay. So what is it clear to you? And remember this formula V is equal to R omega, which you are going to apply. You should apply in case of circular path only. Okay.
Okay, sir.
In case of circular path, you should apply this. You can't apply everywhere. Clear? Circular
Yes,
curve.
sir.
When I think I have you remember omega is V perpendicular by R. This is what I have explained. Perpendicular only we are taking. Okay.
Okay, sir.
All the concept I have already explained to you. So angular momentum of the body will be L1 plus L2 plus dash 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 Ln. Okay.
Okay, sir.
Then summation of this. Okay. And what is this? Actually, mr square m1 r1 square is the moment of inertia of single particle. Okay. Once you sum
Okay,
up,
sir.
then you will get the total moment of inertia. This is for, I'm writing for ith particle. Ith particle. MIR1 na? What is this actually? I is equal to 1 to MIRI square. Okay.
Okay, sir.
L omega. Is it okay?
Okay, sir.
Okay. So actually this is what it is the, if you do the summation of all the moment of inertia, you will get the total moment of inertia, that is I. Okay. So L will be I omega.
Mm,
Remember one thing, this formula you should apply only where? In case of rigid body. Okay. Whole body.
Okay.
This formula, whole body. And you know the derivation it is coming from the particle. On this formula I, L is equal to M R cross V. Okay.
Sir, voice is breaking, sir.
Am I audible now?
Yes,
Hello.
sir.
This formula you
Sir,
should
yes, sir.
apply mr cross v for particle. Okay.
Okay, sir. Okay, sir.
And direction, I think you are remember you have learned cross product. Okay. R cross v. Clear?
Yes, sir.
So L is equal to I omega, L is equal to mr cross v. You should learn this. Okay. Is it okay? Now conservation of
Okay,
angular
sir.
momentum tomorrow, maybe not tomorrow. Day after tomorrow, I will start conservation of angular momentum. Till today, what you will do, you will solve the numericals of this chapter. Okay.
Okay, sir.
Is it clear to you?
Yes, sir.
And this formula which I have written now, you should you should be more and familiar. Like the center, this particle, for example, this particle is moving with v1 velocity. Its position will be r1. Okay.
Okay,
So
sir.
answer moment of angular momentum will be for this particle m r cross v1. Okay.
Okay, sir.
Now you must remember r cross v. If I open this, it will be r1 v1 sine theta. So what is theta? Theta is the angle between. We can like this is the angle. Okay.
Okay, sir.
Is it okay to you? R. It is the
Mm,
angle between R and V. Is it clear to you?
yes, sir.
Okay. Now, no need to worry regarding numerical also. First, you try to understand this concept or thoroughly. Maybe tomorrow I will discuss numerical also, how to approach numerical. See, concept is different in physics and understanding numerical is different. You can check like parallax theorem. When we learn, we are not getting anything. But once we solve the numerical, we are getting a lot of things. This is the magic of physics. Clear?
Oh, okay, sir.
Okay, thank you so much, Dinesh. Take care.
Thank you. Bye, sir.
Okay.
Okay.